the course introduction I'll give, which we will deliberate throughout this semester. Myself, Shakib Ahmed Khan, and I'm professor here in the department. And because of the COVID and all, we are not able to interact with each other. Anyway, we hope that before leaving the before finishing this program, BTech program, will be again able to unite together physically also. We'll see each other and we'll do many things, whatever we are missing because of the physical attendance. And anyway, through virtual tools, we are able to interact and whatever we can do, and we'll try to make use of it, as best of the our ability. Will try to I'll try to share my knowledge and you try to learn, and try to make this class as interactive as possible. So if you feel any difficulty at any point of the time when we are discussing, you feel free, like you're sitting in the class, you feel free to ask, and it will be good if you are interacting. It will be encouraging for me also, because I'm sitting in front of screen and um, nobody is there, and we are not used to such kind of situation. But anyway, so this course is basically electrical and electronic instrumentation. You had already studied one course, I think, earlier. That is measurement and instrumentation, measurement and measuring instruments, that you had already done. So in this part of this course, we'll discuss about measurement of circuit components, you can say. Your first unit is totally devoted to measurement of resistance, and then measurement of second unit is about measurement of inductance and capacitance and frequency, mutual inductance also. And then next unit is about the transducers and signal conditioning, then oscilloscope, and then some digital and miscellaneous digital and electronic instruments. So this is the broad content of your course. So today I'm starting with the first unit. It is about measurement of resistance. One thing I would like to tell you before starting this unit, that measurement of resistance is not only the measurement of discrete resistance, but it is a measurement of more like measurement of sensor resistance. Means there is a class of sensors or transducers which is called resistive sensor or transducer. Resistive sensor and transducer is a class of sensor which are widespreadly used, and it is preferred also. Means wherever we want to measure anything with the help of sensors, then we try to use resistive sensor first, because it is most simple kind of sensor. So measurement of resistance means measurement of discrete resistance as well as measurement of sensor resistance. And as you know that by using sensor, we measure different kind of parameter. So these methods are basically to measure resistance of a resistive sensor, so that we can measure different parameters to which your resistive sensors are sensitive to. So we'll discuss, it will come. Now, first of all, very basic things today. You had already studied in earlier classes. I'll try to means recapitulate all those things by discussing these topics. these are the terminologies or the definitions, basic definitions that I wish that we should recapitulate, because we'll keep on using all those things many times. So first of all, I'm starting with the measurement. What do you mean by measurement? What do you mean by measurement? Yes, please. Anybody, any of you can speak. What do you mean by measurement? Anybody? G. Measurement is a very, you can say, essential act that we are involved in. We used to, means we are involved from morning to evening. We measure many things. How can you define measurement? What is it? जी बताइए.
So
So
actually,
measurement can be defined as
yes,
a
sir.
process of
Actually,
comparing.
it's a
Like
Uh,
comparison.
one person at a time. Either Mashood or
Yeah,
Fahad.
it's
Any? Mashood. Sayyid Mashood. Yeah.
when we try to compare when we try to compare an unknown quantity with a known quantity, sir, that will be called as measurement.
Correct. Correct. Measurement is essentially an act of comparison between the quantity to be measured and the predefined standard. Predefined standard. Your you want to measure 1 meter length of a cloth, then what we do, we compare that cloth with the predefined standard, that length of 1 meter. Similarly, if we want to weigh, we are want to weight 1 kg, weigh 1 kg apple, then we compare the weight of apple with the predefined standard. Okay, that is your weight of 1 kg, standard 1 kg weight. So this is how measurement is defined. Now, when we are involved in the act of measurement, then obviously we are involved. We want the most essential attribute that we will ensure. It is accuracy. We nobody want to measure anything means inaccurately. Nobody want, unless until your intentions are not good. Otherwise, if we are going to purchase a scale for weighing or for measuring something, then we always ensure that the scale should be accurate to as per your requirement. So how will you define accuracy?
so accuracy can be defined as how close we are to the actual value,
Huh,
the degree
we
of closeness.
generally, yeah, we generally say that true value and measured value. So accuracy is basically measured, because all these things, whatever we are discussing here, they are, means we are quantify them. We indicate them in numerical, in values. So accuracy is not a literary term here, but accuracy is a means we should be able to define it quantitatively. So accuracy is basically, it is a measure that how close is your measured value from to the true value. Or in other terms, we can say that the generally accuracy basically is defined as inaccuracy. Accuracy, whatever we means, when you will purchase any instrument, and you must have studied in previous course also. When you purchase any instrument, if you go through the data sheet of the instrument, you will find accuracy is written as plus minus 1%, plus minus 2%. So accuracy is basically inaccuracy, means as far as its meaning is concerned. So if the instrument data sheet is mentioning that it is plus minus 1%, this means that this instrument, if you are using to measure certain parameter, then at maximum it will give you the error of plus minus 1%. So deviation will be within 1 minus or plus minus 1. It is a kind of disclaimer, and you should know. And if this particular accuracy suits as per your requirement, of the measurement, then you should use this instrument. And if your requirement is you want better result, then obviously this instrument is not good for your measurement. So this is as far as accuracy is concerned, it is pretty relative. Now, after accuracy, I'll come to another parameter that is called precision. How will you define precision? Precision many times is inaccurately used in place of accuracy. But precision and accuracy, both of these things are different things, pretty different. So that's why I'm asking, what do you mean by precision?
Sir,
So it
minimum
means the
error.
close.
So precision
So
All
can
right.
it
be
is quality of being exact. How
Fahad,
close we are
let
to
the
the
other person. Fahad, let the other person. Yes, yes, please.
So
Roll number
minimum error.
54. Roll number 54.
so precision means how close two or more measurements are to each other.
How close is?
So it means whatever the measurement is between two. Suppose we have taken a scale and measure something. Then it is how close we are. Uh, how close the date. How close uh, how close the value and the measurement
Readings are.
will
If you are
to
taking
each
more than
other.
one reading, then what is the degree of agreement among the readings? You want to tell this thing? हाँ भाई मोहम्मद एहतशाम, you are speaking, you are telling something.
So being exact, quality of being exact.
Being exact.
Yes, sir.
What do you mean by being exact?
For the minimum error value.
But it is then it is accuracy.
मैं सर
Yes, please. Anas Khan.
सर अगर हमने जैसे डिफरेंट रीडिंग्स ली हैं किसी एक पैरामीटर के लिए, तो जो दो दो रीडिंग लिए या तीन लिए, उनके बीच की जो क्लोजनेस होती है सर मेजर्ड
Okay.
वैल्यूज में.
Okay. Okay. Mohammad Fahad, you was also trying to tell something.
यस सर, काफी हद तक पॉइंट सर अनस का ही रखना चाहता हूँ सर. मतलब अगर हम एक से ज्यादा रीडिंग लेते हैं और उनके बीच में कह सकते हैं कि एग्रीमेंट है, और कोई इंस्ट्रूमेंट एक से ज्यादा रीडिंग में और सेम वैल्यूज दे रहा है लगभग, तो हम कहेंगे वो काफी प्रिसाइज है कम्पेयर टू द अदर इंस्ट्रूमेंट. अगर वो एक ही वैल्यू के लिए हम बार बार मेजर कर रहे हैं तो अलग अलग रीडिंग दे रहा है तो प्रिसाइज नहीं है वो. अगर वो सेम वैल्यू को हम मेजर कर रहे हैं उस इंस्ट्रूमेंट से तो वो प्रिसाइज माना जाएगा अगर वो सेम रीडिंग दे रहा है ऑलमोस्ट.
Correct, correct. So most of you are having idea about the precision. Precision is basically the measure of repeating ability of an instrument. So I'm giving you one example, then things will be clear. Suppose you are having 2 voltmeters and you are measuring 5 volts 5 times with these 2 voltmeters, and 1 voltmeter is giving 4 volt each time, and another voltmeter is giving 4.8, 4.5, 4.5.5, and means different reading, but not deviating more than suppose 0.5 volt. But the first voltmeter is giving consistent value, that is 4 volt all 5 times. So we'll say that the meter 1 is more precise but not accurate, but meter 2 is more accurate but less precise. So this is fine to all of you.
यस सर.
So
Yes,
this is measure of repeatability, repeating ability of an instrument, and this is again, I'm telling you, this is a very important attribute, and we want that every instrument should be precise, because if you are taking a reading, you're suppose you are weighing yourself through the weighing scale, and every time you are putting your weight on the scale and you are getting different reading, then it is very difficult to comprehend that what is the exact reading. So precision is also one of the essential. So accuracy and precision is one of the important and essential attribute of any measurement system. Now, instrumentation, as the title suggests, instrumentation means, I would like to explain at the onset that instrumentation means sensor-based measurement system. Sensor-based measurement system is called instrumentation. Instrumentation. Instrumentation system means sensor-based measurement system. So in this course, we'll discuss ultimately the different kind of sensors and their application and their issues and their signal conditioning. Instrumentation system is basically a multi-stage system where the sensor is the integral part of it. So this is so at the onset, I want that you should know what is the instrumentation system. Wherever instrumentation system comes, this means it is a measurement system and is having a sensor with it in it. And then there are many times you will find that the signal which we are getting out of sensor in response to the certain parameter which we are interested in measuring, it is not up to the mark and compatible to the next stage. So we require to condition it. So there are many imperfections, and we try to remove these imperfections using suitable signal conditioning circuit. So the signal conditioning circuit is another part of our instrumentation system, and generally you will find it is also an integral part. So sensor and signal conditioning is an integral part, but signal conditioning is not one thing. It is a wide and variety of circuits. They are used to address the variety of the issues. They are called signal conditioning issues. So that we'll touch upon also in certain unit, and then oscilloscopes and all these things we'll discuss. Now I'm coming back to with this general discussion on many things, and as later on also whenever we require to discuss something which you had already studied or you are yet to study it, but it is required here, we'll time to time we'll discuss all these things. Now my slide is visible to all of you.
Yes, sir.
Now I'll come to the measurement of resistance. Resistance, you know, it is a important electrical parameter, and it is important as it is also a circuit component. And then again, I'm saying, as I told you earlier also, that resistive sensors are used to measure different non-electrical or industrial parameters like temperature and strain and stress and pressure and weight and all these things. Many things resistive sensors are involved in measuring. Many chemical sensors you will find, all pollutions. Most of the sensors which are used to measure the environmental pollution, they are resistive sensors. So many means, as I told you earlier also, that resistive sensors are preferred wherever we require any instrumentation system. We try resistive sensor. If resistive sensor solves the purpose, then we stick to it, because it is a very simple type of sensor. So these method which we will discuss here, they will be used for measurement of discrete resistance as well as the sensor resistance. So you keep this thing in your mind, because many things we'll discuss with a reference to the sensor based measurement. So you should not confine yourself only the discrete resistance application of these methods to the discrete resistance. It is widely used and for measurement of sensor resistance, and accordingly we'll discuss whatever is the required, because requirement of measurement of discrete resistance and measurement of sensor resistance are different, and we should keep this thing in our mind. Only then we will be able to discuss these methods and their issues and how these issues are taken care of. All these things we'll discuss here, and many resistance measurement methods you are already aware of. Now we'll go through those methods also, and simultaneously we'll discuss the finer points also. Now, first of all, I'm coming to the classification of resistances. This is a broad classification. I'm not saying that it is very stiff classification, but obviously when we are talking about any parameter, not only resistance, any parameter for the purpose of measurement, then obviously we can classify it into low, medium, and high. And here also the resistance values which we from measurement perspective. I'm talking from the measurement perspective. So low resistance, medium resistance, high resistance, these three classification is done, and then certain ranges are defined. So the main range is the medium resistance, that is between 1 ohm and 100 kilo ohm. And again, I am telling you that these ranges are not very, means boundaries are not very stiff. That medium resistance is only means you will have the idea. Means I'll discuss many things, then you'll have the idea. But broadly, it is 1 to 100 kilo ohm, and low resistance obviously below 1 ohm, and high resistance is above 100 kilo ohm. This classification is done on the basis of measurement. What is the meaning? Meaning is that the methods which are the means not in the measurement of resistance only. If we are talking about the measurement of certain material, then the larger value, certain parameters, sorry, then larger value measurement and smaller value measurement is always a challenge. Accurate measurement of larger value of certain parameter and smaller value of certain parameter is always challenge. So the easiest range from measurement point of view is medium range. So here also the easiest range is your medium range, and whatever method mostly you are aware of, they are used for the measurement of medium resistance. But these methods, if we are using for measurement of low resistance or high resistance, then they will not fetch you the accurate result. Are you able to understand this thing, whatever I just now I spoke?
Yes, sir.
So the medium resistance methods, the medium resistance is easiest to measure from the accuracy prime point of view because it is having less issues. But if we go for the measurement of low resistance, so and we are using methods, those methods which are used for measurement of medium resistance, then it won't fetch you the correct accurate result. And similarly, when we go for the measurement of high resistance, it is having different issues, and the medium resistance methods which we are using to measure the medium resistance is we are using for high resistance, then it won't fetch you the accurate result. Your results, your measurement results will have more error. So because of that, this is the criteria for the classification. Then we have one set of methods to measure medium resistance, and then if we want to use, because your medium resistance measurement is having minimum issues, and that's what we call moderate range. And then if we are going for any extreme, whether we are going for the higher value or we are going for the lower value, in both the cases you will find that there is a lot of issues. And unless until the methods which you are using to measure the medium resistance, if these methods are catering those issues, only then they will be able to measure the low and high values accurately. So I'm starting with the medium resistance measurement. Now I'll ask to you, means you are already aware of the different method for measurement of resistance. Now tell me about the methods. Only I'm asking the name of the methods which you know, through which you can measure medium resistance or resistance, by matter of fact, resistance. If you know the methods which can be used for measurement of resistance, you tell me the name.
So Wheatstone bridge.
Yeah, Wheatstone bridge is one of the methods, and here I will tell you that it is used for measurement of medium resistance. Any other method, more simpler method? Wheatstone bridge is a good method, and it is a complex method also. Any simpler method?
सर एक ओम मीटर मेथड भी होता है सर.
ohm meter is, you can say that a method which directly measures the resistance. This is another method, but although ohm meter method is not good method, but it is of direct reading type, so its use is easy. So another method, that's correct. Both the
Multimeter.
methods are used for measurement of medium resistance. Yes, please.
Sir, ammeter volt.
Multimeter.
Ammeter voltmeter method. The simplest method is ammeter voltmeter method, and that uses Ohm's law to measure the resistance. So you all know that voltmeter ammeter method. How can we use voltmeter ammeter method? Can anybody explain how? I'm starting with the, so now I'm means summarizing our discussion on measurement of methods used for measurement of medium resistance. So voltmeter ammeter method, then Wheatstone bridge method, ohm meter method. So these methods, if anybody knows any other method, you can tell me right now. Otherwise, we'll proceed. Okay, so I'm coming to the voltmeter ammeter method. So actually, there are the one more method that although the method which you missed, it is not that much popular, but it is better than ammeter voltmeter method. So ammeter voltmeter method, substitution method, Wheatstone bridge method, and ohm meter method. Now, as far as I'm starting with the ammeter voltmeter method. These all methods are used for measurement of medium resistance. Now, I will I'll ask you what is voltmeter ammeter method. Any of you? I know you are aware of it because it is taught in school itself.
So we take voltmeter and ammeter readings and then calculate the total
We take the
resistance.
ratio of it, voltmeter to ammeter reading, and we get the resistance.
Yes, sir.
Okay. So is this method is having any issue like this? So very simple. We obviously connect the resistance, the unknown resistance, across the voltage source, and then we'll connect a ammeter in series with the resistance and voltmeter across the resistance, and then we take the reading of voltmeter and ammeter, and then we'll take the ratio of these two, and it will give you the value of resistance. So is this method, voltmeter ammeter method, whatever that the circuit diagram is shown here and the method I described, it is having any issue?
Yes, sir. Firstly, the loading of the voltmeter and the voltage drop across the meter.
सर वोल्ट yes sir
What is it?
करेगा और रेजिस्टेंस का मेजर करेगा सर.
So what you are saying here?
sir it actually does not give the measurement across the resistance only which we have required. But it also gives the measurement of the other wires resistance which is used in between them.
Okay, now it is good that you are coming up with the issues in this circuit. So you are saying that there is two issue. One is the lead resistance.
I'm saying that actually the wire which we are considering short circuit wire, मतलब सर उसमें रेजिस्टेंस नहीं होता उनकी एक्चुअली उनके पास भी तो कुछ एक तो फाइनाइट रेजिस्टेंस होता है ना.
So that's what I'm saying, lead resistance. Okay.
Yes.
So lead resistance you are saying is a pertinent issue in this circuit. Any other thing?
एमीटर पे जो
एमीटर का voltage drop हो रहा है सर.
वो भी
Ammeter
measure कर लेंगे.
voltage drop is another issue.
Yes, sir.
So again I'm coming to, that's correct. Any other thing?
Yes, sir. voltmeter में भी सर करंट का लीकेज होगा. So some amount.
वोल्टमीटर में करंट का लीकेज होगा.
Yes, sir. क्योंकि some करंट तो वो भी ड्रॉ करेगा सर अपने आप को, मतलब
That won't affect as far as this circuit is concerned. This circuit, that thing will not, because somebody told that in this case, listen me carefully. if we are talking about the voltmeter ammeter method, so if your ammeter is indicating the value of current through the unknown resistance and voltmeter is indicating the voltage across the unknown resistance, then, and if we are taking the reading of these two voltmeter ammeter reading, if such kind of means indication is there, then it will give you the accurate result. So here in this circuit, the main issue is basically the voltmeter reading. Here your voltmeter reading is not equal to the voltage across the resistance, but it is a voltage across the resistance and voltage across the ammeter, because your voltmeter is connected across the series connection of ammeter and unknown resistance. Okay, so whatever you people told me, I just try to summarize it. As far as lead resistance is concerned, lead resistance is very small and we try to keep the lead length also smaller. So in medium resistance measurement, lead resistance is not of that much importance. And another thing is that you can say that it depends upon your accuracy requirement also. So the most pertinent issue in this circuit diagram, whatever I had shown here, that is called voltmeter ammeter method. One circuit diagram I had shown here. So in this case, the whatever if we are taking the reading of the voltmeter and ammeter, and then we are taking the ratio of the voltmeter reading and ammeter reading to calculate the value of the unknown resistance, it won't give you accurate result because of the voltmeter reading. Here your voltmeter reading is equal to the voltage across the resistance as well as voltage across the ammeter. So I try to write it like this. Measurement value of the resistance is V upon I, and VR is the voltage across the unknown resistance, and VA is the voltage across the ammeter. And since ammeter and resistance are connected in series, so they are carrying same amount of current. So we can write voltage across the resistance is I into R, and voltage across the ammeter resistance, ammeter is I into RA. So your measured value, you can see that although we are trying to measure this, if your measured value is equal to unknown resistance, then we'll say that result is accurate. But you see, your measured value is not equal to the true value, but it is true value plus ammeter resistance. So the ammeter resistance is basically which you are finding out in your result. It is basically error. This is your error. So this is the issue you are having with voltmeter ammeter method with this circuit. So I will analyze it further. Then I am just writing this expression in another way, that is true value is equal to measured value minus your ammeter resistance, and then I had written in a particular form. So in this case, few things I'll try to mention here, that your measured value in this circuit, in this method, the measured value will always be more than the true value. And the measured value is more than always your true value, whatever is the true value of the resistance. And this deviation is because of your ammeter resistance. So I had written this expression in this form also. Now I'll come to the error, relative error rather. So you can see that means in this case, if RA is 0, obviously your measured value will be equal to the true value. That's what, but this is not possible. This is not possible, at least at the room temperature. This is not possible. So error, if we calculate the relative error, measured value minus true value upon true value, so we'll get this expression. So your relative error will be equal to obviously your ammeter resistance divided by your true value. So error in the measurement will be small if the value of resistance under measurement is large compared to that. So this is the general comment. Again, I'm telling you, means whatever method we'll discuss, every method is having certain issues. But if we are using those methods judicial, no method is kind of primitive or obsolete. All methods are equally valid, and they are having its pros and cons. And if certain method suits you, then although it may be not a very good method, but if it suits and it is simple, then we will go for that. So like if we are talking about the measurement of resistance, and if from accuracy point of view, from resource point of view, and from simplicity and from economy point of view, if ammeter voltmeter method suits our measurement requirement, then we'll stick to it, although it is not a perfect method. And again, I'm telling you, none of the method is perfect method. You will find certain issues, but if you are using it judiciously, then it will fetch you a good result. Like here, you see what is you should know why we are discussing all these things. We should know what is the issue with the method, and then we try to compensate. This is always desirable, that if we are talking about certain measurement method, then we should be aware of the issue associated with that method, and then we try to compensate it, means within the circuit or within the system. And if it is not possible, then at least you should know how much error is there, systematic error is there in your reading. So that's what we have done here. So we know that this is the general expression. This is not a specific value. This is the general expression. So with this general expression of the relative error, we can say that if the measurement value of the resistance, means within a this method, this particular circuit is good, if your resistance value which you are measuring, it is at the higher side within the medium range, then obviously your relative error will be less. And if this value is at the lower side, so obviously this method will give you, although there is no problem in the method, everything is fine, everything is in order. But when your method, because from this expression we can conclude that if this method, this circuit is used for measurement of higher value of resistance within the medium range, then it will fetch you better results in comparison to the lower side resistances. So are you able to understand whatever I spoke about this circuit and this method till now? If you are having any question, you can ask, please.
No, sir.
Now I am coming to the next level. So whatever issue this circuit is having, you are means we are able to discuss it in detail. Now how can we tackle it? How can we handle it within the method? We are not saying that we will have another method. No, within the method, how can we tackle it? Whatever issue this circuit is having, how can we tackle it? What is the issue with this circuit? That your voltmeter reading. Your voltmeter is basically the voltmeter reading is, again I'm telling you, this method will give you accurate result only only in the condition when your voltmeter reading is equal to the voltage across the resistance and ammeter reading is current through the resistance. So in this case, your voltmeter is not satisfying the condition, and it is the voltmeter reading is equal to the voltage drop across the resistance and voltage drop across the ammeter. Now how can we handle this imperfection present in this circuit? इस सर्किट में जो भी प्रॉब्लम है उसको हम कैसे टैकल कर सकते हैं? हम ये चाहते हैं कि वोल्ट मीटर में जो है वो वोल्टेज जो ड्रॉप हो रहा है रेजिस्टेंस अक्रॉस, it should give that voltage. So we can change the position of voltmeter and ammeter. This we can try this. Obviously this circuit will not have this issue. Whatever issue we have discussed here, this circuit, the alternate circuit, although method remains same, it is also a voltmeter ammeter method or ammeter voltmeter method, whatever. But whatever issue we were having earlier, it is not present here. Now we'll take the reading of voltmeter reading and ammeter reading, and will it be equal to the true value?
No, sir.
Why?
No, sir.
This time the issue is with the ammeter reading, sir.
Correct. Now this time the issue is with the ammeter reading. Okay? Okay to all of you? किसी को कोई क्वेश्चन है तो पूछ लीजिए. These circuits are very simple, but it is widespreadly used in competitive examinations as well as in interviews also. And mostly, this is my experience I'm sharing with you, mostly people are not able to give the answer. This is very fundamental things, and very simple also, but I found many times that people are not able to give the answer. So this is the time to understand these things properly, and if you are already aware, then try to be in more in depth, you try to find out if they are having any conceptual issue. So here you see, in this case, although whatever issue this circuit was having, that is taken care of here, because what we did, we put the voltmeter across the unknown resistance. So now your voltmeter is giving the correct reading, means whatever is desirable, it is giving that. But your ammeter reading it is having a problem now, because your ammeter reading is equal to the current through the unknown resistance as well as current through the voltmeter. Although you know, in this case, your ammeter resistance is always very small, right? Because ammeter should be it should be ideally it should have zero resistance. So this drop will be very small. RA is of very small value. So that's why I'm saying that here, if your unknown resistance is higher, then your relative error will be. Here in this case, in case of voltmeter, although your voltmeter resistance is always very high, and obviously the current through the voltmeter will be very small, but whatever value, but it is finite value, so obviously it will affect your result. So here in this case, you see, if we are talking about the measured value, it is V upon I, and then I is made up of two, it is having two components in this circuit, the current through the voltmeter and current through the unknown resistance. And obviously both of them are parallel, so the voltage will remain same. So V upon RV plus these currents I had written here, V upon RV and V upon R. Then I try to simplify it. Here you can see, if you look upon this, then you will find that measured value will always be less than, unlike your previous case. That's why we are analyzing. We are trying to, without experimentally using the verifying the results with the expression. That's why we are doing all these things. We know everything about the circuit. So in this case, whatever value you will calculate, that will always be less than the true value. There is a deviation, but in both the circuit, but in the different directions. So here, unlike your previous result, now we further simplified it, and then I had written it in another form. And here you can see that this is equal to 1 upon 1 minus RV. Just after simplification, we have written it. And obviously RM2, if RV is very high, that is ideally it should be infinite, then issue will be resolved, because if it is infinite, then IV will be 0, and means it is open circuit, and R will be. But that is always that is not true. Means it is not possible also. So this is an imperfection in this circuit. And what are the difference in the result of both the circuit, that and what is the final expression that I had given here. Now certain approximation I'm making, although this is the exact expression, the true value in terms of the measured value and voltmeter resistance. Now we'll make certain approximation so that we can have a comparison with the previous circuit. So generally, RV is very high in comparison to the known resistance. So we can take this ratio very small, and that's true. So this expression can be written, approximated by this expression. Means if you take the values which satisfy this condition, then you calculate the true value with this expression, and with this expression, they will be very close. I'm not saying that exact same, they will be very close. So this expression can be approximated by this expression, provided this condition is true. And in this case, as I told you, measured value resistance will always be less than the true value. Now, relative error expression I had written, and then we are able to approximately find out this is equal to. Now I'm coming to the point. In previous case, your relative error was basically measured value or true value, whatever. RA upon R, and here it is R upon RV. Now you see, both of these two methods, two versions of a same method, they are basically they are not accurate methods. Means whatever reading we'll get out of whatever result we'll get out of measurement using these two circuits of the method, these two versions of the method, both of them will give you the erroneous result. But if, and we know how much error is there, and so from these errors expressions, we can conclude that the first one, this one, is good when your unknown resistance is at the higher side. So it will fetch you less relative error. And this is good when your unknown resistance is at the lower side, and this circuit will fetch you the better results. So in general, we can say that this circuit is good when your unknown resistance is at the lower side, and this resistance is good when the unknown resistance is at the higher side. Are you agree with this conclusion?
Yes, sir.
Yes, sir.
Now, where is the boundary? Where is the boundary?
सर अननोन रेजिस्टेंस का
The
पहले से
unknown.
आइडिया नहीं हो सकता ना कि वो स्मॉल है या हाई है.
ये क्या कह रहे?
सर अगर हमें ये मालूम नहीं है कि वो अननोन रेजिस्टेंस स्मॉल है या हाई है, तो हम सर्किट कौन सा डिजाइन करेंगे?
नहीं, ठीक है, दैट इज नॉट अ बिग डील. हमको कभी कभी मतलब ये जनरली एक आइडिया होता है कि ये हायर साइड में है या लोअर साइड में. यू नो, एक कंडक्टर है तो जाहिर से लोअर साइड में है, तो बहुत टाइम हमको आइडिया होता है कुछ. ओके, so in that kind, जब कोई आइडिया नहीं, then it is means you are free to use any of these two methods or both of them, or any of these two methods you can use. You can find the value, and then you can find out कि it is at the higher side. If it is higher side, we'll use suitable circuit. So that is another issue. But if we are making certain conclusions here on the basis of analysis of these circuits, so one of them, भाई एनालिसिस में तो कोई परेशानी नहीं है. एनालिसिस के बाद जो हम कंक्लूजन, उसमें तो किसी को कोई परेशानी नहीं है. हाउ विल वी यूज इट, दैट इज अनदर इशू. Now I'm saying that one of the circuit is good for higher values, one other circuit is for lower values. Then where is the boundary? कोई बाउंड्री तो होगी ना, जिसके ऊपर वो यूज करेंगे, जिसके नीचे इसको यूज करेंगे. How will you find the boundary? सोचिए इसके बारे में जरा. By that time I will take your attendance. I think all of you are aware of your roll numbers. So I'll call by your roll number and you respond quickly so that I can finish your roll number 1.